Hi everyone, I am Yamini, Department of Computer Science and Engineering, SNS College of Technology. Today we are going to discuss about separate chaining. And this topic comes under hashing and sets for Unit 4.
That is, welcome to this session on separate chaining in hashing, part of the Unit 4 in a data structure course. In this video, we will explore how separate chaining works, why it is used, and how it is helps resolve collision in hash table. Let us begin with a quick overview, that is a separate chaining. In separate chaining, it is one of the most common technique used to handle a collision in hashing. When two or more keys are mapped to the same index in the hash table, a situation known as the collision, separate chaining solves this by storing all these keys in a linked list at that index. This ensures that no data is lost even when multiple keys share the same hash value. Let us recall about a hashing, that is before driving deeper. Let's quickly recall the basis of hashing. Hashing is a process of mapping a large data sets of variable length into smaller, a fixed size value using a hash function. A hash function is a data structure used to store these values. However, collisions are inevitable when two keys hash to the same index, and that is where technique like separate chaining comes in. This topic is discussed with this presentation, that is what is hashing, what is separate chaining, collision and application. Next one, the problem for collision. In problem for collision, that is collisions are unavoidable, that is known as a birthday paradox in hash table. In the number of keys increases, the change of two keys sharing the same index rises dynamically. These collisions solve down operation tuning and identically constant time, that is big O of 1. And operation into big O of n is the worst case. That is why it is important to use an effective collision resolution method. This is a diagrammatical representation of problem of collision. Next one, that is in a separate chaining, each index in a hash table contain a pointer to the linked list. When a collision occurs, the new key value pair is simply added to the linked list and at that index. Next one, during a retrieval, we hash the key to find the correct index and then traverse the linked list to locate the keys. Next one, in a ideate stage, we brainstorm way to manage collision efficiently. One simple and efficient idea is to use linked list at each hash table index. This design allows easy insertion, deletion and searching without losing any data, that is flexible, memory efficient and easy to implement. Next one, prototype. In a prototype, that's let's look at the implementation. Each slot is in a hash table point to the head of the linked list, and then head of the linked list. Next one, each slot in a hash table point to the head of the linked list. When inserting, we create a new node containing the key value pair and attach it to the linked list. For retrieve and deletion, we traverse the list at the index until the matching keys is found. Next one, testing. In a testing, that is, next comes a testing. We inserting a multiple key to ensure that the collisions are properly managed. We verify that all collated elements are sorted in a correct linked list. When we test the search, insertion and deletion operation to confirm that no data is lost or overwriting. Next one, application. In applications, separate chaining is widely used in real-world system. For example, including a database indexing for faster data retrieval, caching system that store frequently accessed data, and associative arrays or dictionary in programming language. Every network routers are hashing to quickly look up routing information. Thank you.